Okay, you'll have to tell me what's on it because I'm not able to read it on the scopes here, but you just tell me what's on the slides as they show up. So, thank you very much, Carlos. And on behalf of the United Nations Environment Program, let me congratulate IIASA on its first 40 years and wish you many more decades of success. From the perspective of UNEP, you're needed more than ever, because I can't imagine how complex things have gotten and how much scientists have to learn to work with policymakers and vice versa. I can tell you we have a long way to go, and IIASA has an important contribution to make. I had the pleasure of spending my entire 30s here at IIASA, and I have quite a few stories to tell, but I don't think it would be a good idea if I told them to you now. So instead, what I'm going to tell you about is global water scarcity, and not scarcity from the perspective of volume and quantity, but scarcity from the perspective of quality. And not water quality from the perspective of drinking water quality, which is very crucial, but instead this time water quality with regards to the world's freshwater ecosystems. Because I'm convinced that we're faced now with a global water quality challenge having to do with freshwater ecosystems in the world. And one of my messages is that we simply don't know enough about it, which means that I don't have the facts and figures at my disposal. So I'll be a good scientist, and instead of giving you various conclusions, I'll give you just assertions. I'll give you 5 assertions about what I call the global water quality challenge. And the first is that in developing countries, they are now experiencing a rapid degradation of water quality. That graph you see on the left side comes from the Millennium Ecosystem Assessment. It has to do with scenarios of increasing wastewater discharge up to the 2050s. The dark area refers to river basins in the world expected to have at least a doubling of wastewater discharges up to the 2050s relative to a reference point around 2000. And for sub-Saharan Africa, what these scenarios say is that what's expected is an increase somewhere around 3.5 to 5.5 times the volume of wastewater of the 1990s, early 2000s. Now, no problem with wastewater discharges as long as they're treated. That's what's interesting about the right side map. That shows you some results from a UNEP study, which shows those circles refer to the percentage for the different regions of the wastewater that is either treated or non-treated, where the red color refers to non-treated. And you can see that for most developing country regions, most of the wastewater is untreated, and it's expected to remain so. We roughly estimate, and we need better estimates, but we roughly estimate that somewhere around 10 to 20% of all the wastewater generated in developing countries is treated, and at best only partially treated. Now, what's happening? Why are we having this water pollution problem now emerging in developing countries? Ironically enough, I think it could be a side effect of actually a good development, namely that we are actually attaining MDG 7, having to do with providing enough, or at least increasing the coverage of improved water supply systems in developing countries. We are on track to meet this goal by 2015, maybe you've heard. But what's turned out is the hundreds of thousands of water supply systems that have been built in connection with this goal, partly at least, have not made provision for the treatment of the wastewater produced by these new water supply systems. You have the situation now where the waste remains in the communities, which is not a good situation, not any better than what's happening now. But now this waste is being collected, concentrated, and delivered to the rivers and lakes in developing country regions. Why are we concerned about that? Well, first of all, one outcome is that we're contaminating lakes and rivers that were not contaminated before. And you should know that even though we're improving the quality of drinking water, still a lot of people come in contact with surface waters to clean clothes, to bathe, etc. So we're actually creating a public health hazard here. Secondly, there's the issue of food security, as the outcome document of Rio+20 stressed very strongly. Now I have some statistics, not as big as Ulf's statistics, because I'm only referring to the freshwater system. But you may know that 95% of the output of the inland fisheries in the world are in developing countries, and that's because nearly 3 billion people in the world depend on fish for at least part of the animal protein. Ulf told you about what the 1 billion that principally depend on it. So partly, we use an estimate of 3 billion, okay? Thirdly, it's also an economic issue. If we're trying to build a green economy in the world, like the nations of the world have told us to do at Rio+20, then we have to keep in mind things like inland fisheries play an important role in this green economy. In fact, the gross market value of inland fisheries just in the tropics is around $6 billion per year. And also, it is an important source of income in places where income is really needed. About 3.5 million people in Africa are fishers, and if you add up all the fishers in the world plus the fishing industry associated just with the freshwater ecosystems, not including the marine statistics that Ulf was talking about, you're talking about around 60 million people being employed just in freshwater. So we have an issue here that has to do with health, has to do with food security, has to do with the green economy. Now, I would argue also that this water quality challenge is bigger than a few watersheds in the world. It's bigger than the national basis, that has true global connections. One connection it has globally is with climate change. What you see here are some data from Lake Tanganyika showing the trend in temperature of Lake Tanganyika from the 1920s, showing an increase in temperature that at least the authors here associated with anthropogenic climate change. Now, why are we concerned about increasing water temperature in the tropics? The higher the water temperature, the lower the dissolved oxygen, and for many systems also, the lower the production, the lower the fish production also. Also, climate change, as you well know, will be decreasing precipitation in some areas, lower precipitation, lower river runoff, much lower dilution capacity for the existing wastewater discharges, decreasing water quality. Now, I would argue also that there are many other global connections here. Many other global drivers, not only climate change, but you have the long-range transport of air pollutants that's depositing heavy metals and trace organics in the headwaters of our water supply systems up in the upper watersheds, that you have international consumer product trades, which is leading to the use of pharmaceuticals around the world, and eventually the residuals of these pharmaceuticals are finding their way, unfortunately, into our lakes, into our rivers, not only in developing countries, but in developed countries also, increasing what scientists call endocrine disruptors, the various kind of substances, organic substances, that can disrupt the hormonal systems, first of all of aquatic life, and then also perhaps of humans that come in contact with them. Then it's also a matter of not only of global drivers, but also global impacts of degrading water quality. For example, its impacts on biodiversity and food security, like I've mentioned already. And then you have the global institutions that, because of their development projects, will have a profound influence on water quality around the world. Now, my fourth assertion is, in fact, that while we have this challenge facing us, we also have a lot of options that we didn't have in Europe and North America when we started worrying and contending with our own water quality challenge 40 years ago. For reducing the discharge of pollution, now there's well-worked-out methods for constructed wetlands, low technology, low chemical demanding, low energy. For reducing the source of pollution, you have now various clean production methodology that we can draw on. And we have new management models that we've developed and been working on over the years that we need to expand to include water quality, models of IWRM and concepts like payment for ecosystem services. Fifthly, my last assertion is the following, and that is that all of these good options available in this challenge we have to deal with, we will not be able to deal with it successfully unless we have a solid, real science policy partnership. And I would say this partnership has to concentrate on three big things over the coming years. From the governance standpoint, we have to expand our institutions from local to international to include water quality management, whether it has to do with incentives or regulations that require enforcement. We need to get going now to make sure that water quality management is as included as water quantity management is in our institutions. Secondly, as I said at the beginning, we don't really know what's going on. We need urgently to assist policymakers to work with them in priority setting, where they should put the big investments, where the global environmental facility should intervene in order to protect international inland waters, for example. For that, we need to launch global and regional assessments, and we need to do it urgently. And for those to work, we need to support those assessments, and we need to support them for example, by developing international guidelines, water quality guidelines for ecosystems, so we have a benchmark to judge our performance in protecting water quality and our management strategies. And secondly, we need, as scientists always say, we need to expand monitoring, we need to expand the data collection. Now I'm really serious that in water quality we really are in the dark and need to support the development of models and assessments, etc., with a good database. I'm happy to say that as of 2013, the United Nations Environment Program, working together with UN Water and GEMS Water, will be launching a global water quality assessment in which we're going to try and get this agenda going, and we'll need your help and the help of many other scientists around the world to do that. So finally, 5 assertions. First one being that we believe that in developing countries, they are faced really with rapidly increasing water quality degradation now, which will have implications on health, food security, as well as the economy. That it's more than a local, it's more than a developing country problem. This is a global challenge, but we have some new and good policy options that we can draw on, but it's going to take more than the science community. It's going to take more than the policy community. It's going to take both working very closely together to deal with this challenge. So let's get going. Thank you.